Hello students, today we see the second part of the division method to find out the square roots. We'll take some more problems of the perfect square roots and then we'll see some decimal fractions whose square roots are perfect. So let us take some problems here. The first problem is we have to find out the square root of 3136. 3136. So, starting from right to left, make the groups of 2's. As we have seen already, get this down here. So, 31, 36. Now, first group is 31. So, which is nearest perfect square of 31? Obviously 5. 5 square is 25. So the first divisor is 5, first quotient is 5 here. I'll subtract 25. So that gives me 6 here. And according to the first rule, add the quotient to the divisor. So 5 plus 5, 10. Now, take the next group down. So according to the second rule, suffix a number to 10 and multiply by the same number. So, which number I can suffix? Suppose I suffix 5 and multiply by 5. That gives me 525. Let me go one step further. Write 6 and multiply by 6, which gives me 636. So the next divisor will be 106. In the quotient, write 6 and add 6 to the divisor, which gives 112 here, and subtract 636, which gives the final remainder 0. And that means the square root of 3136 is 56. Are the steps okay with you? Let us do one more problem on the square roots of, that is square root in the perfect form. Let us consider the square root of 8836. Square root of 8836. So do the grouping from the right to left. So 88 and 36. Now first group is 88. So which is the nearest perfect square to 88? That is 9. 9 square is 81. So first divisor is 9 here. Quotient is 9. So I am subtracting 81. So here I will get 7. So I will add the quotient to the divisor. So 9 plus 9, 18. And get the next group down, 36. So to 18, suffix a number and multiply by same number. Now you can see here, the first two digits are 73 and this is 18. So which is the possible number you can write? Try for 3. 183 multiplied by 3 is 549, which is less. So go for the next digit, 184, and multiply by 4. 184, you multiply by 4, you will get 736. That means the next divisor is 184, next quotient is 4. So add 4 to the divisor, that is 188 here, and subtract 736. That gives the final remainder 0, and which will mean square root of 8836, 8836 is 94. Are the steps okay with you? Let us take now a problem in which we will find out the square root of a decimal fraction which is in the perfect form. So consider this: square root of 72.25. Now whenever there is a decimal point, how you do the grouping? On the left side of the decimal point, starting from right to left, make the groups of 2, and on the right side of the decimal point, starting from left to right, make the groups of 2. So in this case, the first group is 72 and the second group is 25. Now to 72, which is the nearest perfect square? Yes, 8 square is 64, 9 square is 81, so 8. So first divisor is 8, first quotient is 8, so I'll subtract 64 from here, so I'll get 8 here. Now according to the rule given, add the quotient to the divisor. 8 plus 8, 16. Now after 72 there is a decimal point, so give a decimal point in the quotient and take the next group down, 25. Now suffix a number to 16 and multiply by the same number. So since the first two digits are 82 here and 16 5s are 80, so I can try for 5. Write 5 here, multiply by 5, and I will get 825. That means next quotient is 5, the divisor is 165, so I will add the quotient to get the new divisor, that will be 170, and I will subtract 825 from here, which will give me the final remainder as 0, and hence the square root of 72.25 is 8.5. Let us take one more problem to make this concept clear. So let us take square root of 174.24. So on the right of the decimal point, starting from left to right, make a group. On the left, starting from right to left, make the groups. So your groups are, first is 1, then 74, and then 24. So now the first group is 1. So take the nearest square of 1, that is 1 itself. So first divisor is 1, first quotient is 1. I am subtracting 1. So this is 0. Now add the quotient to the divisor. 1 plus 1 is 2. Take the next group down. 74. So to 2, suffix a number and multiply by the same number. So since the first digit is 7 here and the divisor is 2, try for 3. So suffix 3 and multiply by 3. 23 3s are, that is 69. So the next quotient is 3. The divisor is 23. So add the quotient again to get the new divisor, and that is 26. Now here you will subtract 69. 23 3s are, which gives you 5 here. And get the next group down, 24. Now to 26, suffix a number and multiply by the same number. Now since this is 524, that is first two digits are 52 and the divisor is 26. You can see 26 2s are 52, so try by 2. Suffix 2 and multiply by 2, and that will give you 524. That means and after 74 there is a decimal point, so put a decimal point here. So the next quotient is 2. So divisor is 262. Add the quotient 2 here. So that will give you 264 here. And subtract 524, which gives the final remainder 0. And that will mean the square root of 174.24 is 13.2. So this is a method by which you can find out the square root of decimal fractions as well as square roots of irrational numbers which are imperfect in the nature. Irrational square roots rather, not square roots of irrational number, irrational square roots like square root of 2, square root of 7, which we'll see in the next class. Okay, so just go through these concepts. Thank you students. See you in the next class.